If we go over the sheet here, just these first two are what I would call pretty basic ones in terms of, so this graph is positive just for this little stretch here. So that'd be from negative infinity to 0. It's when the graph's above the x-axis. And then it's negative from 0 going on to infinity. This is the part of the graph that's below the x-axis. And then for the zeros, when they have it on here, it's just, does this graph have any zeros? And if so, where are they at? This one has one at 0. So like over here, if you go look at the zeros on this one, you see a 0 at -4 and a 0 at 2. Same concept. In terms of positive and negative intervals, you can have more than one. Like this graph has a single positive interval from -4 to 2, but it has two separate negative intervals, which is why I have two intervals up here. This one that goes from negative infinity to -4, and this one that goes from 2 to onto infinity. So those are a couple of really good, just kind of straightforward examples. And there's some other ones on here. This is a good example of one that has no positive part, which makes sense. This graph never goes above the x-axis, so it has no positive interval. It's then technically got two negative intervals because right here it's 0, so it's not technically negative. So that's why you have a 0 at -2, then you have two separate negative intervals. And one of the things you're going to notice with sheets like this is, we didn't go over every possible thing that can happen in the notes because that's like impossible to do. There's so many different kinds of graphs that you kind of got to just critical think on some of these and figure out, okay, yeah, I can have more than one interval, or it's possible to have no intervals. Like, so this one, you have two of each intervals because it's positive here and it's positive here. So that's why there's two separate intervals. It's also negative here and negative here, which is why there's two negative intervals. There's three different zeros at 0, 2, and 4. And so you see all that on there. The last two positive and negative problems were these two. Same deal, nothing too crazy here. There's two positive intervals for this one negative interval, and then two zeros. Over here, two of each. You have a positive interval there and there, a negative interval there, and three separate zeros. So there's your positive and negatives, intervals, some examples there. You'll notice everything on here uses parentheses. And that'll always be the case because when you're at 0, you're no longer positive or negative. That's why it never includes those values. So all parentheses across the board when you're talking positive, negative intervals. So then if we flip over, we look at the increasing, decreasing stuff. Maybe. Did it stop recording? Oh, now we're back. Okay. So anyway, I had I said, up here, don't do these first two parts. Just do the increasing, the decreasing, and if they have any parts that are constant. So here, this increased twice. It increases here, so negative infinity to 0, and it increases from here on, so from 2 to infinity. So again, increasing and decreasing, we're talking slopes now. This graph, the only time it decreases is from here to here, so that's from 0 to 2. Here's a good example with what we call some constant areas. So again, this never increases. It's always either constant or decreasing or constant. So it has one small decreasing interval from -2 to 2. And then two intervals where it stays constant or stays flat. That's this one and this one. And then just looking ahead to some of these other ones. This number 3 here, this is a pretty straightforward one where you've got a decreasing interval right here. So from negative infinity to -1 was the decreasing. Your constant right there, so from -1 to 1 is constant. And then you're increasing here. So from 1 on to infinity, this graph is increasing. So that's a good one that shows all three possibilities. 4 is tricky. So 4 I want to just talk about for a minute, and then I'll just kind of flip down to the bottom ones there. 4 has like two separate, or looks like two separate graphs on one thing, but it wants you to talk about it all as a whole. So if you just, again, read the graph left to right, the graph starts off increasing. So from negative infinity to this point, which is at -2, it's increasing. So I wrote that down. And then at this point, it decreases. So from -2 until it gets to this little dashed line, it decreases, which is at -1. So it's just a really small decreasing interval. And then the separate graph starts up here where it's still decreasing. So that's from -1 to 0. This graph decreases. And then from here out, it increases. So from 0 on to infinity, it increases. That's a funky one. We don't see those ones too often where it's like two separate split graphs. There's a name for this we get into later on. It's called an asymptote. That's not super important for a long time, though. Then we have a couple other graphs. This is where we start getting into some of the little more complicated things that can happen in them. Although I say this one I wouldn't say is too crazy. This one basically increases, decreases, increases, decreases. So it's got 2 of each interval there. This is one that's broken up where it increases, it's constant, and then it increases again. So it's got 2 increasing intervals and no decreasing intervals. So we got all kinds of different little combinations of things that can happen on these. And sometimes these are really simple, sometimes they're a little crazy, and it just kind of varies from problem to problem. And then here's these last 2. This is actually probably the easiest one. This one only decreases. It doesn't do anything else. So from -7 on to infinity, it decreases, and there's nothing else going on in the entire graph. So probably the simplest one there. And then this one, bunch of different chunks. You got a decreasing chunk, an increasing chunk, and then a constant chunk. You're just describing each one of those as an interval. So really solid in terms of just checking that you kind of get it all.